Alright, what's up guys? Mr. Fabella here with a lesson starting off chapter 3 with algebraic expressions. So first of all, before we even start, algebraic expressions. What does algebraic mean? So first of all, let's break this down. Expressions. We've done expressions before. So that's like kind of a number sentence, a math sentence. So 3 is not an expression. 2.5 is not an expression, right? 3 plus 7 is an expression. 8 minus 5 divided by 2, that's an expression. So, and then the difference between an expression and an equation has an answer, an equal sign. So we're just talking about expressions. So 7.5 minus 2.5, that's an expression. That's a numeric expression. What makes an algebraic expression an algebraic expression instead of a numerical expression? That would be an algebraic expression has constants and variables, or the main difference is that it has variables. If you forgot what constant is just like a regular number. No x, no y, nothing, just like 5, 2.5, -3, pi, all of those things, those are constants. An algebraic expression has a variable there with it. So like 2x minus 5, x minus 3, y plus 7.2. Those are algebraic expressions. All right, so now that we have that out of the way with our definitions here, so let's start thinking about different examples of algebraic expressions. Okay, let's think about different examples of algebraic expressions. So here, try to find a strategy to write an expression for each problem. So here, you wash cars for 2 hours, you receive $6. How much do you earn per hour? So how much do you earn for 1 hour? So per means usually, you're dividing it like how much for 1 hour. So if you're getting $6 for 2 hours, how much do you think you make in 1 hour? Okay, so yeah, exactly. You're going to do, if it's $6, you're going to divide that by 2 hours, right? So $6 divided by 2, or $6 over 2 hours. If you divide those two numbers, 6 divided by 2, let's put this in red, that's $3, and then per hour. And as you can see there, I wrote it this way, but it's kind of easier to see since dollars are on top. It's $3 over 1 hour. So 3 over 1, because if you simplify this fraction, it's 3 over 1, or just 3. But that kind of shows you why it's per hour, right? It's $3 and then a slash and then hour for 1 hour. So that's what that means. Okay. Yeah, so get another look at an example here. You have $60. You buy a pair of jeans and a shirt. The pair of jeans costs $27. There. You come home with $50. How much did you spend on the shirt? So what do you think you would do there to find out how much you spent on the shirt? So you could do a couple of things. You have $60. You could go $60 minus how much you spent on the pair of jeans. So 60 minus 27. So that would be $33. That's how much you spent on both of those. Okay, so $60 minus $27. That is how much the pair of jeans cost, right? So then you have $33. Well, the leftover information is you came home with $15. So if you subtract $15 from that, and we don't need to put these dollar signs here if we are subtracting money. We can just put it at the end. What's left over from that is going to be 18. You have $60. You spent $27 on the jeans. You still had $15 left, so that means what's left over after you subtract all of those is you have $18. So the shirt, and you can go ahead and check that to see, okay, well, all my money, right? I spent $27 on the jeans. I spent $18 on the shirt. If I add that up, I get $45. $45 plus my $15 of change leaves me with $60. So I did this correctly. So check. Okay, so here's some definitions as we were talking about before. An algebraic expression is an expression that may contain numbers, operations, and one or more symbols. Parts of an algebraic expression are called terms. So here's the important parts. The symbol that represents one or more numbers is called a variable. So because it could be whatever. Any number possibly can be, like p here could equal 5 or 7 or 2.8. The number in front of a variable that's multiplied by the variable, the numerical factor of a term that contains a variable, that's what this means. The number in front of the variable, that's called the coefficient. So it's like right next to it. So if it says 5p, that means 5 times p. That's called the coefficient. And a regular number, a term without a variable, that's just called a constant. It's called a constant as opposed to a variable because a variable could be whatever you want it to be, right? It could be 7, -8, 2.5. A constant is what constant means. Constant is it's constantly 7 or it's constantly 4. It can't be anything else. It's 4. All right, good. And so let's identify the terms, coefficients, and constants in each expression. So here I have 5x plus 13. This 13 is the easiest one to spot because there's no variables there. So that's a constant, right? The x here is a variable. So a symbol, a letter that represents some number that you don't know, it's a variable. And the number in front of the variable, that's going to be the coefficient. So coefficient. And it's you don't really write it as x5 just because even there, I tried to write it straight. If the number comes after a variable, it looks like an exponent. So don't write it after. So it means multiply. So it's 5. It's the same as this, 5 times x, or in parentheses like that. And that's why we don't use the x for multiplying anymore, because that looks weird. But that means 5 times x. Right? So that's why we don't really use that. We use the dot or the parentheses. Okay? And technically, yes, if you're doing 5 or x times 5, that does mean x. It's the same thing as 5x, but normally we just write it as 5x so you don't have to put the dot there. Okay. And this one, identify the terms, coefficients, and constants in each expression. So I did not do the terms here. The terms are 5x and 13. Okay. The terms here are 2z squared, y, and 3. So terms are separated by addition or subtraction. Okay. And here, let's see, coefficients, constants in each expression. So here, the 2 is the coefficient. Okay, z is the variable, and we'll say a variable because there's another variable here. This y is a variable, and the 3 right here is a constant. It's a number by itself. Okay, good. And as you can see here, they did it very neatly. The terms, you do the terms first, and then within the terms, you have the coefficient, which is 5, and then the constant, which is 13. And then here, write each expression with exponents. So this is a d, and it happens 4 times. So it's d to the 4th power. And this is 1.5 times h times h times h. So 1.5 still stays there, right? 1.5. And you could say times, but I don't need to, because if a variable is next to a number, that just means it's multiplying. So h here, and then there's 3 of them. So h to the 3rd power. Okay? Now evaluate. Evaluate means whatever, so right now it says k plus 10. K can be anything you want. Over here, it actually says k equals 25. So when k equals 25, what does this equal? So that means it's giving you what the variable is, and so you just plug it in. Whenever it says evaluate, you're going to plug that in here. So it's k plus 10, right? But instead of k, you put in the 25 plus 10, and that's going to equal 35. So evaluate just means you plug it in. Same thing here. The n is going to be 12. So you just need to plug in the 12 to where the n is. So 4 and then times 12. So that gives you 48. And then things can get a little more complicated or intense, right? now this is more, so x equals 5 here. So the 5 goes where the x is, and then you just rewrite it. So 3, and then since the x is there, it's saying times, right? So you could put a dot or put whatever you're evaluating in parentheses. So it could be like that. That means 3 times 5. Just don't write 3, 5 like that, because then you'll think that's 35, which it's not. And then you just follow order of operations from here. So 3 times 5 is going to be 15, minus 14, that's going to give you 1. Same thing here, right? This is z equals 2. You put the 2 over there, and you rewrite it. 2 squared plus 8.5. So 2 squared is 4 plus 8.5, and then that gives you 12.5. So here's a problem here. You're saving money to buy a skateboard. You begin with $45 and you save $3 each week. The expression 45 plus 3W, that's the amount of money you save after W weeks. How much will you have after 4 weeks, 10 weeks, and 20 weeks? After 20 weeks, can you buy the skateboard? Explain. So you can just make a table like this where the number of weeks here, 4, 10, 20, right? And then you plug it in. This 4 goes where the W is. The 10 goes where the W is. 20 goes where the W is. And then you evaluate that. And so after 4 weeks, you get $57. After 10 weeks, you get $75. After 20 weeks, you get $105. So after 20 weeks, you have $105. The skateboard over here says it's $125 for the complete. So unfortunately, you cannot buy the skateboard just yet. But with this, when we do equations, you'll be able to solve exactly how many weeks would it take to purchase the skateboard. So yeah, if you're watching this on YouTube, in the comments, put how many weeks do you think it'll take to purchase a skateboard. So that's about it for the first section of chapter 3 of algebraic expressions. Hopefully that was helpful, and I'll see you guys at the next one.